Okay, we're gonna take a look at a couple of tricky log equations. So the first one we'll look at is this one. Okay, now what makes this tricky when you compare it to the ones we did in the last video? Well, what makes it tricky is that the word log is written twice, which presents a problem because in order to use that definition, right, to write it in exponential form, we need the word log written once, and we needed to get it by itself, and then we can use that definition. But the word log is written 2 times. That's not necessarily a problem though, if you recall, and so this is what makes this the tricky. This is what makes this the tricky problem. Recall that a property of logs, and again, Mrs. Adams made a nice video. It's on my website under Get Ready for Advanced Math if you want to review log properties. The log of a product of something times something is equal to the log of the first thing plus the log of the second. Okay, that's a key property because it works in both directions. In other words, if I have the log of a sum, I can rewrite it with the word log written once and vice versa. So if you look at our problem for the moment, and I actually need to change this. I need to make these 2's. Make those a 2. Copy the problem wrong. Sorry about that. Those are 2's. You'll see why later. We need to rewrite. We're going to rewrite using the property of logs here. We're going to rewrite the left-hand side as log of x times x minus 6. Because in this problem, that x is like my m, and that x minus x is like my n. Right? When you look at the property there. So log base 2 of x times x minus 6 equals 4. And, if you want, remember this is all being logged. If you want at this point too, you can distribute that x. And so now we have that. And this is what we want because the word log is written once, it's isolated, so I can use this relationship and rewrite the equation in exponential form so that the word log isn't even there anymore. Okay, and so now we're not done. Now we're going to solve for x. And in fact, I really should make that clear at the beginning. Solve for x. 2 to the 4 is 16. That equals x squared minus 6x. And at this point, it's a quadratic. It's a degree 2, so I have to set the equation equal to 0. Or change the equation so that one side is equal to 0. And I think we all know what to do now. Hopefully this factors. It does. That's why I changed that 3 to a 2, because I wanted this to work out. If it didn't factor, you'd have to use the quadratic formula, which we all dread. But I think this factors. 16, I think we get an 8 and a 2. And I think that's got to be the negative. Right, and so now we've got x plus 2 times x minus 8 equal to 0, which means that x plus 2 equals 0 or x minus 8 equals 0. X equals negative 2 or x equals 8. Now before we go ahead and just start circling our answers here, we have to plug in these values back into the original. The reason is because sometimes algebra is not like alive. It doesn't know what our original equation is. Sometimes you'll do the algebra and you'll get answers that don't make sense afterwards. Okay, now like the math doesn't know that. We have to know that. So what I'm saying is to check, I'm going to plug negative 2 back in. Log base 2 of negative 2 plus log base 2 of negative 2 minus 6. Does that equal 4? Well, I claim that this is not going to work. The reason is because log base 2 of negative 2 is not a number. Neither is this. That's the log base 2 of negative 8. It's not because, remember, you can't take logs of negatives. And there's a lot of ways to think of that. One is the domain of a log function is 0 to infinity. Right? The other way to think about it is log base 2 of negative 2. If that equals something, that means that 2 to that something equals negative 2. But you tell me the power I can raise 2 to get a negative number. There is none. All right. So what we say is that negative 2 is an extraneous solution. Okay, it doesn't work. Okay, so that's not in our answer. But x equals 8 does work, I believe. So log base 2 of 8 plus log base 2 of 8 minus 6. See, does that equal 4? Well, log base 2 of 8, that's the number you raise 2 to get 8. That's 3. Log base 2 of 8 minus 6, well, that's just log base 2 of 2, right? The number you raise 2 to get 1, to get 2, it's 1. And that works out, right? So we did it right. So notice that the only answer is x equals 8, even though our work produced 2 possible answers. Okay, so that's a tricky problem. You'll get a little bit of practice in class, but just keep an eye on that and keep this because it combines a lot of stuff: algebra 2, concepts, logs, a lot of good stuff, log properties. All right.